Hi, my name is Veno. I want to talk to you today about the Spatiotemporal Epidemiological Modeler, known as STEM. Now, this is a free open source software available through the Eclipse Foundation. This software was originally developed by IBM Research, and it's a graphical based simulation engine for spatiotemporal modeling. What happens is that in this software we have this geographical visualization of the spread of disease using internally implemented graphics and Google Earth, and we have various models of infectious diseases inbuilt within the software that you can use. This is a software that can be used by public health professionals, researchers of infectious diseases, people who are interested in studying infectious diseases. So we have different models like the SI model, SIR model, SER model, deterministic and stochastic model. And in the software we have inbuilt maps of about 244 countries of the world, and we've made provision for air transportation, ground, land transportation using vehicles or train or whatever, so that you can simulate the spread of an infectious disease in a particular population. STEM implements Java-based component software architecture, and we have plugins that can be used independently. You can develop, you can share those plugins and do a lot of stuff with STEM. You can even create your own models for a country, for a region, and this is an open source free software, and you can download it from these websites, especially www.eclipse.org/stem/downloads. Okay, you can download the software, install it to your computer, and then you can start using it. It's a free software. Now let me show you what STEM looks like, on your laptop. This is the STEM interface. On the extreme left panel there, you can see this is where you have your STEM projects. For example, I have a project here called cholera. I've attempted to simulate the spread of cholera in a certain African country. If there is a bioterrorist attack using cholera as a bioagent, I've attempted to simulate. Perhaps we could just have a brief look of what this really looks like when you're simulating. You see, like this simulation using the standard stochastic SEIR model, S for susceptible, E for exposed, I for infectives or infectious people, R for recovered. All right, so these are compartmental models, of disease. You can look at them like maybe rooms in a house. See, maybe a house has 3 or 4 rooms, and you can only be in one room at a time. From that room you can go to another room and then go to another room. That's a similar way to which these models operate. A person might be susceptible today, then later he maybe might be exposed to an infection, or then he becomes infectious, and then maybe recovers, become immune, or become susceptible again. So these are the compartmental model of disease. Now, in this simulation that I'm showing you right now, This is an African country called Nigeria, and we've attempted to simulate the spread of cholera beginning from a city called Kano in Nigeria. You see it, the infection spreading maybe through water sources, in wells and water plants and all that, maybe through food and all that. This cholera epidemic is spreading all over Nigeria. You can see how it's spreading, the simulation. And if I bring my cursor here, I'll be able to see the different towns and cities in Nigeria, and it will give me an estimate. I can see the susceptible percentage, infectives, the recovered, the exposed, all that. I can even see the latitude and longitude, of the particular location. Now you can see the infection has covered almost the whole country. In a short while from now, it will cover the whole country, and here on the lower part of the left panel, you can see the date, being shown of how many days it has taken for the infection to spread around the whole country. Okay, now virtually every part of the country has been infected with this infection, and here you can display and see things like the disease deaths. If you click on it, you see that there are deaths recorded all over the country, okay, as a result of this infection. You can also see a lot of stuff here, the population count susceptible, the incidents, virtually all over the country. If you see these color legends here, they give you a little bit of what you see, on the graphical interface of the maps. Okay, for example, you see the blue color is the susceptible, the red for the infectives, infectious population, the dark color for the count, then you see for incidents, this ash color a little bit, the yellow color for the exposed, green for recovery, like that. All right, so you can always use this stuff. Let's go back to the designer's perspective. There are different perspectives in the STEM software. Now go back to the designer perspective, and let me try to minimize this. So if you want to maybe do your own model of spread of infection using STEM, what do? Now you can go here. Here you see new STEM project. This is what you use to create a new STEM project for maybe simulation of a disease spread, and a lot of other things that you can use in STEM, hopefully.